So here I have myself a massless spring, and attached to it is a block. And the spring has a spring constant of 4 newtons per meter. And gradually I am applying force to this block as I push it towards the left of its equilibrium position. And let's say that the energy being delivered to this block is a constant rate. It receives the power of 3 watts. So my question to you is that when the block is displaced 3 meters from its original equilibrium position, let's say this is x equals 0, the equilibrium position, at this point when it is displaced 3 meters away, what is the instantaneous change in the location of the block? So essentially I'm asking to find dx dt. So let's say we have this like as our x-axis, and we want to find the instantaneous change of the block along this axis at the time when it is located 3 meters away from its equilibrium position. So to find this, we want to find a relationship between the power and the change in the position. We want to exploit a relationship. So what do we know about power? Power is the instantaneous change in energy over time, with respect to time. Okay, so what about energy? Energy, we know, is force times dx. In the case of a spring, we know that the equation for the potential energy of a spring is half kx squared. So basically all we have to do, we already found a relationship between energy and x. So if we differentiated this, we would be able to find the relationship between power and the change in x. So let's do that. We differentiate both sides, so we'd get dE dt is equal to half k. Now here's the tricky part. We have x squared, but we're differentiating with respect to time, not with respect to x. So essentially this is a chain rule problem. X itself is a function of time. So what we'd get is 2x, and now we differentiate for x, giving us dx dt. At this point, this problem just becomes a simple substitution problem. So we get dE dt, which we know is also the power, which is 3 watts. And we know that, well, this simplifies down to 2kx dx dt. And so if we put in our, oh sorry, that's actually kx dx dt. So if we substitute for k and x, we'd get 3 is equal to, 4 times 3 times dx dt. So if we solve for dx dt, we would get 1 over 4 meters per second. So that is how you can do a related race problem.